In example 2, the function is f of x equal to x cubed, and we are looking for the derivative again one more time. So let me start with the derivative, f prime of x. It's going to be the limit as h approaches 0, and again, difference quotient, f of x plus h minus f of x, all divided by the h. And that's the long way of doing things. Ultimately, we're going to have a formula that helps us solve this problem in no time whatsoever. But for now, this is how we're going to be doing it. So let's look at each part separately. So first of all, there's going to be a fraction. There's the h on the denominator. There's a minus in the middle that we have to keep track of. So let me put that minus in the middle. And next, let's look at f of x plus h. What does that even mean? The x plus h just literally means put x plus h into the function x cubed. So erase the x cubed and replace it with x plus h, and you get x plus h to the power of 3. So that whole expression that I just wrote, x plus h to the power of 3, replaces the f of x plus h. Next, we want to write down the actual f of x itself, and that function in this problem is x to the power of 3. So again, we are going to repeat the same steps that we did on the last problem. We're going to FOIL and multiply out everything. And let's see. So what happens when I FOIL and multiply everything? So first of all, it's going to have a massive fraction right here. And we're going to multiply the x plus h to the power of 3. So I'll show you how to do that in a second, but let me write down the answer for now. X cubed plus 3x squared h plus 3xh squared plus h to the power of 3. Then minus the x to the power of 3. So this minus right there is the one that was in the middle. And all of these terms came from FOILing the x plus h to the power of 3. And again, I'll show you how to do that at the end of this problem. So we don't forget about the h on the denominator. And at this point in time, if we're doing things right, a lot of terms should cancel. And the things that are left should have an h in them. So look at the x cubed at the beginning and the negative x cubed at the end. They cancel. All the ones that are left will have h in them. And that's expected. So since we're noticing the pattern, what we're going to do next is factor the h from the terms of the numerator. So we're going to take away the h from each one of those. So this one has 3x squared h. They will be left with 3x squared. The next one has 3xh squared. We're going to take away the h. We're going to be left with 3xh. And the final one has h cubed. That's 3 of them. We're going to take away 1. We'll be left with h squared, 2 of them, all divided by the letter h. And now we take this h and that h and we divide them out till we get 1 and 1. So this is the limit as h approaches 0. And now we have 3x squared plus 3xh plus h squared. Notice how I keep writing limit, limit, limit on every line, okay? At this point in time though, I'm going to recall that the h is approaching 0. So which letter gets replaced with 0? It's the letter h because of the notation that's written. So that right there is going to become 0, and this one right here is going to become 0. When I do that, I get 3x squared plus 3x times 0 plus 0 squared, because the h is turning into a 0 because of the limit. And when you add and multiply and subtract and whatever, do all the things that you have to do here, we end up with 3x squared. So that's what we call the f apostrophe x, meaning the derivative of the function f of x. Now, how do you actually go about FOILing the x plus h to the power of 3? Well, there are different ways of doing this. One way is to write it down 3 times in a row, x plus h, and then x plus h, and then x plus h again, because x plus h to the power of 3 just means write it down 3 times and then FOIL the whole thing. If you did that, you would have to do 2 of them at a time. So let's leave the third one alone and just FOIL the middle 2, or the first and second. So we get x squared plus xh plus xh again plus the h squared. Let me make some space. So plus the h squared. This is literally x squared plus 2xh plus h squared, all multiplied by x plus h. And now you FOIL 1/3 time. So x squared times x is going to be x cubed. Then x squared times h is going to be x squared h. Then you multiply 2xh with x, you get 2x squared h. Then you multiply the 2xh with the h, and you get 2x h squared. Then h squared times x is going to be h squared x. And then finally, h squared times h is going to be h to the power of 3. At this point, we're required to add like terms. So the x cubed doesn't have any friends, but x squared h has some friends. So there's an x squared h here, and there's another x squared h right there. So together, that's going to be 3 x squared h's. And then the 2xh squared and h squared x are like terms. So when you add them, you get 3xh squared. Then finally, the h cubed doesn't have any friends, so we're just going to put it at the very end. And this is the answer that I had put earlier into the problem right there on that spot. That's how I got it. But there's also a formula that you can memorize. And if you memorize the formula, you can pretty much skip all of this work and just use the formula, do it mentally, basically. As you can see, it took forever to get the derivative in this problem. Ultimately, we're going to have a different method. Ultimately, we're going to have something called a power rule that will help us out when we see things like x to the power of 3. The power rule will basically say if you want the derivative, all you have to do really is just do a couple of things. Slide this 3 to the front, and you end up with 3. And then the 3 that was in the power, take away 1 from it. So 3 minus 1 is going to be 2. And that's how we're going to be doing the derivative in the next section and for the rest of the semester. We're not going to be doing the limit with the difference quotient forever. We're just doing that right now so you can see the relationship between the derivative and the original function and the slope of the tangent line and the slopes of the secant lines. That's why we're doing it this way. But ultimately, once we finish this section, we won't be doing limits of difference quotients for the rest of the semester. We're just going to be doing this new technique called the power rule. It's kind of like a shortcut that takes you from the first line all the way to the last line in one single step, rather than doing everything else that we did in this problem. So that's where we're going with all this ultimately. So at this point in time, we are looking for f prime of 3. So this problem gave us a 3x squared for the derivative. And since they are writing f prime of 3, that means they want us to erase the x in the problem and replace it with 3. And so when we do that, what do we get? We end up with 3 times 9, which is 27. So what does 27 mean? What is the significance of this number? This is the steepness of the line that we call the tangent line at the point x equal to 3. So this is the steepness of the tangent line at x equal to 3. Another way of saying steepness is to say the slope. So if you don't want to use steepness, you can say it's the slope of the tangent line at the point x equal to 3.